Welcome back. Now let us do the regression hands-on. Please go to the code folder and open regression.r. Yes, good. Okay. Let's start. Line number 2, we are clearing the environment. Line number 3, setting the working folder and setting the seed. Line number 5, getting the data table library because it will be useful for us. And line number 6, getting the util file. And line number 11, this time again even for regression we are going to work with MPG data, and in MPG you know very well the response variable is MPG and categorical column is name origin. So just making a list of it. So I'm running line number 2 to line number 11 in one go. And let us read the data so that we can start preparing. Okay. And line number 13, reading the data from data folder. And line number 14, we are simply, it looks like if you see that there is one space in the column name. Let me show you first that space. I'm running the line 23 just to show you the space. And if you see, this is the space. Can you see the engine displacement? This is the space. And I have observed that few of the library, they don't like a space in the column name. That is one thing. And sometimes that is why the data table, what it does, it replaces the space with dot. Sometimes it replaces with dot. Basically, there is a flag that through which if you say that replace the space with dot, it will do it. Okay. But what we are trying to do, we are trying to replace that space using the underscore. So in line 14 we are replacing that space using underscore. Line 15 we are converting the column name to uppercase, and line 18 we are converting to data type, that categorical column to as a factor. I know that you know all these things. And line 21 onwards, basically viewing the data, that how much data we have, the structure of the data, and then seeing the data. Yes, this is our data we are going to work with, and a basic summary over here in line 24. Okay, that's all. So this is good. I think till now, till this point you are aware of it. Now we are going to prepare the data. See, prepare the data that need to be done irrespective of the problem you are trying to solve. Whether it is regression, classification, or any kind of data mining, analytics, any kind of work you do, you must prepare your data. So it's basically cleaning the data. And the good preparation you have, the better modeling will happen and the better insight will come. So that is a preparation of data we'll be doing here, and this is applicable for any kind of work you do. Okay. Okay. Now let us go ahead. So first what we are doing, we are creating the one hot encoding and scaling. One hot encoding I had already explained, and scale things let me explain to you because this is for the first time. So let me explain the scale part to you. I'm opening the Excel file. There I'll explain you the scale part. Okay. Please see that suppose this is your height column. HGI. This is your height and this is your weight column of the human being, and this person is a 5 feet 5.5 and say 6. This person is a 60 kg, 70 kg and 80 kg, something like that. Okay. When this data goes to the model, these are the numbers. So what the model says, it believes that okay, 60 is greater than 5. And 60 is greater than 5.5, 6 and all. Because these are the numbers. It does not understand the weight, that unit. because the height is in the feet, weight is in the kg or pound or whatever the things you say. But for model, it is a simply number. So to make sure that model understand properly, we bring both column to the same scale. So how do we go into it? So there are a few techniques. Few people scale between -1 to 1, and a few people scale 0 to 1, and 0 to 1 scaling is also called normalization. And whether you should do the scaling -1 to 1 or 0 to 1, for machine learning, most of the times 0 to 1 makes sense. -1 to 1 is also fine, unless the algorithm say that you should scale the data 0 to 1. And when you learn the deep learning, it makes sense. Basically, it has the different meaning when you scale from -1 to 1 and 0 to 1. I'm leaving that. I'm not discussing that because that will be the part of the deep learning. Okay. So now let's go ahead and scale. So what we do, we start having like this. We are going to scale between 0 to 1. So what we do, we put the minimum 0 and maximum 1, and in between is give the proportionate number. So here in case of 5 is minimum and the 6 is 1. And 5.5 falls in between, so 0.5 will be the in between. Weight minimum is 60 is 0 because that is and again here let me make it different, otherwise it's 65. This one says 70 and this one says 65. Okay, so minimum 60 is 0 and maximum 70 is 1. Okay, and 65, let me make it say 64. That then 64, where does it falls? 64 falls between around 0.4. So this is what? This is called normalization or scaling between 0 to 1. Now both are on the same scale, so it can be compared. And now even though it compares, yeah, you see that this equals, and here weight is more, here height is more. So this is comparable. That is what it is called scaling, and now it is on the same scale. So machine learning or mini model really understand in this way. Okay, and for the hot encoding I had already explained, and for hot encoding and the scaling I have written one dummy, this one utility function. This is there in the common util. It takes your the train data table response variable so that it does not touch upon the response, because for the response we never scale, we do not do the hot encoding and so on, and it is taking the list of the categorical column and output is getting saved over here. So when we run it, so I'm going to run the line 29. So it has run, and it is joined, and once it is done, then we can go and see the data. Generally it takes hardly few seconds. Probably let me go and see that probably it is done. It has done. It has done it. Okay, so let me open that file. Okay, if you see this, see all this numeric column, those have been scaled between 0 to 1, and the response variable has never been touched upon, as explained, and the categorical values feature have been hot encoded. So this is what our transformed file. Okay, so that's all for this one, and in the next video we'll start next topic. Thank you for watching it. See you in the next